everybody. It is time for us to go over the 7-3 worksheet about proving triangles similar. For number 11, for each triangle, name the triangle similar to triangle ABC and explain why it is similar. So when it says name the triangle, it wants us to write a similarity statement because it wants us to practice writing in the correct order. So for letter A, I can say the original triangle ABC is similar to triangle, and then when I look at this, I see where the X, the Y, and the Z are. So A to B is X, and then B to C is Y. So I just have to go X to Y to Z. So that would be N, L, that's X to Y, M. And then I have to say Y. So in this case, we're using side, side, side similarity because each of these sides is a scale factor of 1.5. So we can say side, 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 scale factor of 1.5 that is different between them. For letter B, I am using some angle similarity there, and I can say triangle ABC is similar to triangle, naming based on the angles, TSR, and of course that is angle similarity. And we know if two angles are similar, then all three angles will be the same. Number 12, if two triangles are congruent by angle, side angle, are the triangles similar? Yes, they are, because if they're congruent by angle, side angle, then they will at least have angle similarity. So yes, because they will have angle similarity. Number 13, what is Russell's error? So what he did was he said, all right, if I have 180 and I subtract this 60 degree and this 80 degree angle, we get 40. So the unlabeled angle in each triangle is 40 degrees, which means that the measure of angle M is 60. And he's using that to show that there would be a 40 and a 40, a 60 and a 60, and using angle similarity. However, he assumed too much information. He assumed that there was a K or an M angle of 60 degrees. He said, well, there must be a 60 here, there must be a 60 here. But we don't know that until we show that the triangles are similar. So we can't say that there's a 60 here, a 60 here, until we show that the triangles are similar, but that's what we're trying to do. So there's sort of a paradox going on. So we can say Russell assumed that either K or M are 60, or was 60 degrees, which is only true if the triangles are similar, which is only true if the triangles are similar. But that has not been proven. But that has not yet been proven. Because it's possible in this case that, for example, angle K could have a measure of 59 and angle M could have a measure of 41, and the triangles would not be similar. They wouldn't have angle similarity. 15, explain why there is no side angle similarity theorem. So because similarity is related to congruence, being similar means that we are required to be able to show a congruence transformation between the two triangles and then dilate to make them larger or smaller. But there's no side angle congruency theorem, so we can't show that first part of similarity. We can't make them match up with each other by side angle and then dilate to create similar triangles. So we can say, since there is no no side-side angle congruency theorem, you cannot show that a dilated triangle is necessarily congruent. You cannot show that a dilated triangle is necessarily congruent to another triangle using side-side angle. To another triangle using side-side angle. 16 through 18 explain whether each pair of triangles is similar. So we're looking for either side, 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 angle, side, or angle, angle similarity. But if we look at number 16, the ratio of these sides, 11.25 over 7.5, 9 over 6, and 5.4 over 3.8, those are not the same ratios. So we can say, no, these are not similar. The ratio of the sides is not the same. All right, we look at the next one. We have a 60 and a 40 and a 60 and an 80. We can fill in the third angle of those triangles by subtracting from 180. So I have an 80 here and a 40 here, which makes those triangles congruent similar by angle, angle similarity. Number 18, I have a 108 degree angle, and I have on the other triangle a 22 and a 50, which if I subtract from 180 makes a 108 degree angle there. And I have a 6 as my long side and an 8 as my long side of the other triangle, a 3 as the short side and a 4 as the short side of the other triangle. And I know that 3/4 is equal to 6/8. So there's a ratio between those two sides, which means that yes, these triangles are similar by side, angle, side similarity. Number 20, what is the value of x? We are going to think about whether these are similar triangles. And I know using subtraction that there's a 67 degree angle right here. So by angle, angle similarity, those triangles are similar. So I'm going to use some thinking here. I know that there are isosceles triangles. So I know that both sides of this triangle will be x units long. And I can make a ratio because the bases of the triangles are 20 for the small one over 26 for the large one. And then if I'm using the side lengths of the triangles, there is 26 for one of the isosceles sides of the small triangle over x for one of the isosceles sides of the large triangle. Then I can just do cross multiplication. So 26 times 26 is 676 equals 20x. And then I'm going to divide both sides by 20. And that is going to give me 33.8 equals x. So 33.8 is the answer there. Number 19, what is FG? Again, I want to see whether these triangles are similar. And of course, they are similar by angle, angle. So I'm trying to find FG. So I'm going to make a ratio or a proportion here. Use my shortest or my longest sides and my shorter sides there. So I've got 4 over 5, long side to long side, equals x over 3.5, short side to short side. Cross multiply there. I get 4 times 3.5, that is 14, equals 5x. Divide both sides by 5. And I get 2.8 as the value of x. 22, a building manager needs to order 9 replacement panes that are all the same size, each similar to the window itself. At what angles should each pane be cut in order to fit the window? What are the dimensions of each pane? Explain. Well, the angles are really simple because the angles of similar triangles will be the same angles. So since this triangle has sides, it's an isosceles triangle. We can find that out because we know that 96 plus 42 and subtract that from 180. We have a 42 degree angle here. Since all of those little triangles are similar to the big ones, we know the angles will be 96 degrees, 42 degrees, and 42 degrees for each of those small ones. Then we say, well, how can we find the dimensions? And when we see this 60 feet long right here, it's divided into 3 congruent pieces of 20, 20, and 20. So I'm dividing by 3 and getting 20, 20, and 20, which means I'm going to divide the other side by 3 as well. 40.5 divided by 3 is 13.5. So 13.5 and 13.5. So let's explain what we did. We said divide the given dimensions by 3. Divide the given dimensions by 3. And each triangle has base 20. And each triangle has base 20. And congruent sides .5. All right, number 23. The screen of a surveying device is 0.0026 meters wide, really tiny, and is 0.1 meters away from the lens. If the surveyor wants the image of the 2-meter target to fit on the screen, what distance d should the lens be from the target? So here we've got similar pictures. We've got similar triangles. We can tell because they're isosceles triangles that have vertical angles that are congruent. So what we can do is we can make a ratio. We can say, all right, if I use the base of a triangle divided by the height of a triangle, so if I do 0.0026 divided by 1, that should be, divided by 0.1 meters, that should be the same as the base divided by height of the larger triangle, which would be 2 over d. Then I'm just cross multiplying. 0.1 times 2 is 0.2 equals 0.0026d. And then I divide both sides by 0.0026. And I get 76.9 equals d. So 76.9 meters away from the target, which is pretty tall for a drone, I think, but I have no actual idea. 25, which condition is sufficient to show that ABC is similar to QPR? Select all that apply. Well, if RP is equal to 4.5, then that means that I am going to have a side 3 that is corresponding to side 6, side 5 that is corresponding to side 9, and side 4.5 that is corresponding to side 10. That would be sufficient. Also, it gives us side angle side similarity as well. The next one, the measure of angle Q, is equal to 63. If we knew that one, we would say, all right, Q here is 63. I know this is 63. That gives us side angle side similarity. And those triangles are congruent because of that. Sorry, the first one was side, side, side. I think I said side angle side, but side, side there. Side there. And then if we knew that the measure of angle P was 81, we would only know one angle, and it doesn't have included sides that we know. So that's not going to work. Same thing with R. We would only know one angle in this triangle, and we wouldn't know both of the included sides. So A and B are the only answers there. 26, for which value of FJ must triangle FGJ be similar to triangle FHG? So FGJ is this triangle right here. Oops. And we want to say what makes it similar to the whole triangle. So if I'm thinking about this, I can make a proportion, and this proportion is going to include the long side of the little triangle and the long side of the large triangle. I'm going to call that piece an x. So I'm going to say the long side, 18, over the long side of the large triangle, 27 plus x. must be equal to the short side of the large triangle, x, over the short side of the big triangle, 18. We're going to do a lot more of these tomorrow. Then I'm going to cross multiply. 18 squared is 324. That's equal to x times 27 plus x. And what I can do there, of course, is I can say, all right, 324 equals 27x plus x squared. And at this point, I could solve this equation by using lots of different strategies, such as factoring, or completing the square option, or the quadratic formula. Or I could plug in my options to see which one made this side equal to 324. And when I do that, I can pick that C must be equal to 9. All right, if you've got any questions on this, make sure to ask me in class, and have a wonderful day.